All right, welcome back. So I think I found the perfect combination or the perfect setup for this particular type of Newman motor. See the little top I made, little safety top? I don't really need it, but just in case. It is one of these cylinders at 20 millimeters in diameter, and putting the copper foil, the copper sheet, literally halfway around. So half and half, and then it goes right up against it. You can see the little spark there. It's not even, but I can make it even. This guy works perfectly. He just sits, and the brush has a spring on it, and the spring is being pushed against in this little pin here, and the wire comes through and is connected to the top. Now I'm going to connect a voltmeter to this guy and this guy to see what we got going on here, so stay tuned. All right, so it ranges anywhere from 40 volts AC. You can see because it's pulsing, I don't get a steady flow. What I need to do is I need to hook up a rectifier and smooth this guy out. Hook up a rectifier, and probably, I think I have a nice capacitor. So let me do that. All right, stay tuned. So before I hook up all that, I decided to hook up a light to it. This is a 12-volt light, I believe. It's running really good. I'm really happy with this setup here, with the brush going excuse me, against the rod. And this is a simple setup too. I like it. All right, let me put my little top back on there, and let me try to smooth this out with a capacitor. And I'm pretty sure I have a rectifier, so let me dig one out and get it hooked up. Stay tuned. Actually, really quick, I made a mistake in that last entry. This is a 127 volt or 120 volt light. Yeah, so that's pretty cool. 60 hertz, 120 volt light. All right, let me see if I can find the rectifier and set it up. Stay tuned. All right, so I've got this jerry-rigged big time. I got to be careful. But with the smoothing, with the bridge rectifier, I got a cap on there, but the cap's not rated for what it's putting out. It's putting out close to 50 volts. 48, 50 volts. The cap's not getting one. Oh, I just messed it up. Wait a minute. Oh, dagnabbit. There it is. Yeah, it's putting out around 50 volts. So what I want to do now, though, is I want to try something different. I want to try to run this guy off of a Hall sensor. I know that's not the way you're supposed to do. Let me shut them off. I know that's not how you're supposed to do Newman motors, but I've run it off of the JL94 circuit. Now I want to try to run it off of a Hall sensor. What I want to do is I want to put the Hall sensor, I want to cut a little hole here and put the Hall sensor right there. And actually, I may not even need to cut a hole, because as I said earlier, these magnets are powerful. There's the north, there's the south, there's 9 barrel magnets. And when I mean barrel magnets, I mean magnets that are about this size, 1, not 2. This is 2 of them. but there's 9 that are about this size, and they're N42s, and they're on each end there. So I may not even need to put the hall sensor inside. I may just have to put it right next to it and see what happens. But let me set that up. I've been really curious lately to see how that looks. All right, I got to discharge this cap so I don't get zapped. Stay tuned. And I should have recorded that. I discharged the cap using a screwdriver the way most people do, and it was a massive spark, a 50-volt DC spark. Anyway, let me get the hall sensor set up because, again, I'm really curious. Stay tuned. All right, so as I suspected, these poles are so strong, I can use the hall sensor outside of the coil, and it almost started itself. Nice and smooth and quiet. And that's with the hall sensor outside. And it's really cool. The sensor's staying warm, staying cool. Yeah, that's amazing. I wonder how much power I'm drawing from that. So that's at 12.3 volts. I really like this setup. I may even I really like this setup, and it's flying. And that's off of the hall sensor circuit, courtesy of Sky Collection. It's working really good. Yeah, my fear was that because there's so much coil that the sensor itself would overheat. But man, is it quiet compared to the commutator setup. Yeah, I'm going to do some more experiments with this like this. I wonder if I can really quickly see what we're doing here. So this would be DC. Let's see what we got here. There's something wrong with that. I think there's something wrong with my my meter. Maybe it's not DC. I thought he put I thought he set this up with a rectifier. Anyway, I think there's something wrong with this guy. I got acetone on it. But yeah, I really like this setup. Let me the amazing part is everything is staying really cool. I really thought it was going to overheat it. And again, this is outside the plastic housing, the bearing housing that holds the 2 bearings that holds the rotor in place. I really like that. I'm going to play some more with that. Steady state, 12.3 volts. Let's turn it down and see if it'll keep going. There's 10 volts. There's 9 volts, still going. There's 7 volts. It's starting to slow down, which is to be expected. But it's still going. There's 7. There's 6 volts, 5.96 volts. Still going. I put a heat sink on this guy too. When Sky sent it to me, it didn't have one, and this was overheating a lot, which is my fault, not the fault of the circuit. So it's still going. It's going slow, but it's still going at 6 volts. I think it's going to stop, or is it still going? Yeah, it's about to stop. Let me juice it back up again. There we go. 9 volts. Anyway, I wanted to do this. I really wanted to try. I thought about it last night before I went to bed. I said, oh, I'd really like to try the Hall circuit on this guy. And it works really good. All right, guys. Later.